Hi, so for today we're going to talk about the applications of linear equations, and more specifically for this video we're going to solve some problems involving number problems. Okay, and before we start, uh, let me just remind you that whenever we are solving linear equations, we are actually trying to find the variable x. Okay, mostly that's the most common variable assigned to the unknown in the linear equation. And we must take note of the always of the conditions set by our problem. So let's get started. Let's try to solve this one. So when 6 times a number, okay, is increased by 4, the result is 40. Find the number. This is a typical number problem wherein if we start our solution, okay, we must let x what? The number that we're going to find. Okay? So in this case, we have to let x as our unknown number that we are about to solve. As you all know, linear equations, we're going to solve the value of a variable, right, of itself. So when 6 times a number is increased by 4, so let's try to analyze this step by step. Okay, when 6, so it says when 6 times a number, okay, so 6 times the number itself, which is the x, okay, is increased by 4. That's the word increase. Well, actually it's addition. Okay, is increased by 4. It says the result. Okay, it means that the result that is equivalent to equal is 40. Find the number. Okay, the very first thing we do is to set up the linear equation, and according to our problem, we're going to find that number, okay, x. So in this case, we have written already the equation, so we have to find the value of x here. So it's simple. By simple algebra, we have 40 minus 4. Okay, we have 6x. 40 minus 4 is equivalent to 36, and we have 6x here. So if we multiply both sides by 1 over 6 or divide both sides by simply 6, so what will happen is that we have 6x over 6, we have 36 over 6. This would cancel, this would give you x here, and 36 divided by 6 is simply 6. So that is our number. So to check if we have the correct answer, well, if we plug in this x is equals to 6 to this equation, the left side of the equation must equal to the right side. So what will happen? Our equation is 6x, which is 6 here, plus 4 is equals to 40. So 36 plus 4 is equals to 40, and yeah, we got the right answer. 40 is equals to 40. Okay? Let's go now for number 2. Number 2, it says one number exceeds another number by 5. Okay? So, if the sum of the two numbers is 39, find the smaller and the bigger number. Okay? So, if we are going to solve this, the problem clearly states that one number exceeds another number by 5. So, if we let x as the smaller number, okay, that is the x, and there is another number which exceeds this smaller number by 5, it says, so if it exceeds another number, it means we have to add x plus 5 to the smaller number. So this is now our larger number. Okay, that is our larger number. So again, one number exceeds another number by 5. So we have the one number which is the smaller, we let x as the smaller, and a number exceeds another number by 5 is actually x plus 5. Okay? So we didn't label y because the condition is that this another number exceeds the smaller number by 5. So technically speaking, that should be the same x. Okay? So if the sum of the two numbers is 39, find the smaller and bigger number. Okay. So if this is a smaller number, this is the bigger number. The second condition here is that if the sum of the two numbers is 39, find the smaller and bigger number. So we have to add plus x plus 5. Okay? If we get the sum, okay, of these two numbers, it says that it is equal to 39. Okay, by algebra again, x plus 5 is equal to 39. So x plus x is simply 2x. Okay, we transpose 5 on the other side. 39 minus 5. So we have 2x is equal to 39 minus 5, that is 34. Okay, and if we divide both sides by 2, what will happen here? Okay, 34 over 2, this would cancel. X is now equal to 34 divided by 2 is 17. Okay? And this is the smaller number. Okay? Smaller number. Because that is our x. Okay? So how about the larger number, the bigger number? Again, this is the larger number. So you got the x that exceeds by 5, the x. So what will happen? 17 plus 5 is simply what? 22. Okay? This is the bigger number. Okay? Or the larger number, of course. And if we're going to check this, of course, we're going to plug these values in our equations. So what will happen? We have x plus 5, that is our original equation. So x is 17, so 17 plus, we know that 17 plus 5 is 22, and hence we got the correct answer because 17 plus 22 is actually 39. Okay. Okay, let's go now for number 3. It says, if one number is 3 times as large as the another number, and the smaller number is increased by 19, the result is 6 less than twice the large number. What is the large number? Okay, again, we're going to solve this by first assigning a variable. So in this case, we have another number. One number is 3 times as large as another number. So we have two numbers here. We have the smaller number again, and we have the larger number again. Okay? So what will happen here is we're going to let values or let variables. So it says if one number is 3 times as large as another number. So it means that there is a number, okay, and that smaller number we can represent as x because that is the number. The condition is that this larger number is 3 times the smaller of the number because it says if one number, okay, is 3 times, okay, that is the 3 times as large as another number, which is you x, 3x, okay, that smaller number is increased by 19. That is another condition. If the smaller number is increased by 19, that is another condition. So you must first identify that we have two numbers here. And the relationship of the larger number is thrice or 3 times large as the small number. Okay? So before you proceed. So what will happen? And the smaller number is increased by 19. Okay? That's another condition. The smaller number is increased. That's denoted by an add. Okay? The result is, meaning the result is equal, tantamount to the word or tantamount to the operation equal or sign equal. So the result is 6 less than twice the large number. Okay? 6 less than twice the large number. It's tempting to say that it is actually 6 less than twice the large number. Okay? But it's actually wrong. If you see 6 less than twice, you must always put it after the condition of the large of the preceding sentence. So 6 less than twice large number. So this 6 less than must be on the very what do you call this, very last part of the equation. So the result is 6 less than twice. So 6 less than, this is 6 less than, okay, twice the large number. So twice the large number. So again, let's recap. So we have two numbers. We have small number x, and the relationship of the larger number to the small number is that it is 3 times as large. Okay? And we have the following condition again. The smaller number is increased by 19, which is denoted by this. The result is, which is equal, 6 less than twice the large number. If you see 6 less than twice, perform first the second condition after that 6 less than, which is what we did. Twice the large number, okay? Twice, that denotes times 2. The large number is 3x. Then we perform the less than. The less than is actually a subtraction sign. So we have 6 less than the twice the large of the number. So in this case, we can now solve the for the large number. We are after this because that is what our problem is asking. So we have x plus 19. Okay, we have 6x here minus 6, combining like terms. So what will happen is that we have 19, okay, plus 6. I transpose negative 6. So we have 6x minus x here. So what will happen here is 19 plus 6 is 25. 6x minus x is 5. Dividing both sides by 5. So, or 1/5. Multiplying it by 1/5. So what will happen? 25 over 5. 5x over 5. Simply this would cancel. And we are left with 5. Because 25 divided by 5 is 5. So, did we get the answer? No. Actually, the question is, what is the large number? What is the larger number? I mean, what is the larger number? Okay? What is the larger number? This is the smaller number. Okay? The larger number is thrice the smaller number. So, what will happen here? The larger number is 3 times 5, which is actually 15. Okay? This is the larger number. Okay, that must be our answer. Okay? How do you prove? If we have a correct answer, and again, we can always check by our equation. So we can always check. So if our equation is x plus 19 equal to 2 times 3x minus 6, so we know that x is equals to 5 plus 19. It should equal to the right side of the equation. So we know that 3 times x is 15 times 2, because we have a twice here. So that is 30. Okay? 30 minus 6. Okay? And we have 19 plus 5 is 24. 30 minus 6 is 24. So we have the correct answer for that. Okay, let's try again another problem. So it says the sum of the three consecutive numbers is 306. What is the largest number? Okay, so for our solution, okay, we have to determine the consecutive numbers or the largest number. What I mean is being asked in the question. So if we have consecutive numbers, we can represent them as, first, we can let x as the first number. Okay? Well, of course, if that is consecutive, it means that it's consecutive. Okay? So if the first number, for example, is 2, if we say that we have a consecutive number of 2 consecutive numbers, well, of course, we have 2 and 3. So if we have 3 consecutive numbers and if our first number is 2, then we have 2, 3, and 4. So in this case, we don't know the first number, so we label it as x. Okay? And if that is a consecutive number, well, of course, it has an increment of 1, x plus 1. So it should be what? The second number, because it's consecutive. Okay? We need to add 1. So if we have consecutive numbers, we let x as the first number, x plus 1 as the second number, x plus 2 for the third number. Why x plus 2? Because, let's say, for example, if we have the first number which is 2, The next to 2 is 3, which is x plus 1. And the next to 3 is actually 4, which is 2 plus 2. Okay, so we let x plus 1 and x plus 2 for 3 consecutive numbers. Okay, then let's proceed with another condition. So it says the sum of the 3 consecutive numbers is 306. So it means that we can label this. We know already the first 3 consecutive numbers. Okay, we let x for that, x plus 1 and x plus 2. So it says if we get the sum of these 3 consecutive numbers, okay, the answer, okay, the answer is 306. So we have 306 here. And upon having this simple algebra, so we have x plus x plus x, we have 3x. We have 1 plus 2 is equals to 3, is equals to 306. And of course, by algebra, we can get x, okay? So 3x is equals to 306 minus 3. So 3x is now equal to 303. Okay, divide both sides by 3 or multiply by 1/3. So what will happen? 3x over 3 would be cancelled. And we have 303 divided by 3. And 303 divided by 3 is actually 30 divided by 3 is 10. So that is 101. Okay? Now, is this our answer? No. It says that what is the largest number? Okay? This is the first number, which is actually, if we get the largest number, of course, that would be x plus 2, which is the third number. So we have x plus 2. In other words, we have 101 plus 2, and that is equivalent to 103. Okay? If we want to check if our answer is correct, well, of course, we need to have what? We need to perform the same. So this is the simplified equation. So we have 3 times 103, okay, plus 3 is equals to 300, okay, 6. So what will happen here? Okay, no, this is 101. Okay, I'm sorry, because that is the x, 301, 101. So 3 times 101 is 303 plus 3 is equals to 306. So if we add this, the right side, if the equation is equal to the left side. So hence, we got the correct answer. Okay, so that's it. So for number 5, okay, number 5, one number is 24 more than another. Okay, the smallest number is 24% of the large number. So how is this different from our previous examples? So it says we have one number is 24 more than another. Okay, so we have to let again, let's say we can let x as the smaller number. Okay, we can let x a smaller number again. Okay, and also we have again the larger number because it is stated in the problem. Okay, we have the larger number, but take note that we have two conditions here. One number is 24 more than another, and the smallest number is 25% of the larger number. So there must be another variable here, not only x, because we have two conditions. So what will happen here is that we can let y as the larger number again because we have two conditions here. One number is 24 more than another. The smallest number is 25% of the larger number. So one number is 24 more than another, that's one condition, and the smallest number, which is actually the same number, is 25% of the larger number. So we can let y as the larger number. So again, if we have the two variables again, we can what? Proceed now to the conditions. If we have already the variables, if we have already identified how many variables do we have here. Okay, so one number is 24 more than another. Okay, and let us first have this condition. The smallest number is 25% of the larger number. So the smallest number, okay, which is x, smaller number is what? 25%. 25% is actually 0.25. And if you convert this into fraction, that is one-fourth. So we have the smallest number is 25%. That is one-fourth of the larger number. Okay? That is our first equation. Okay? And one number is 24 more than another. So, if this is the larger number, okay, then definitely this is equal to y. Okay? One number, that is the larger number, is equal, okay, 24 more than another. So, we have x plus 24. So, this should be our equation 2. So as you can see here, we have two variables. And of course, if we have two variables, we need to have two equations in order for us to solve these two variables. So because that is what the problem is actually asking. Find the two numbers. Okay? So we can actually substitute or express equation 1, okay, in terms of, let's say, we need to cross multiply this. Okay, so what will happen here? If you multiply both sides by 4, so what will happen? We have 4x is equals to 4 over 4 times y. This should be equal to 1. So we have y is equals to 4x. And we can substitute this equation, y is equals to 4x, to equation 2. Okay? For us to solve the x. So we have, if we have this equation, y is equals to x plus 24, okay, y is equals also to 4x. We have x plus 24. Can we solve for x? Yes, we have 4x minus x is equals to 24. So that we can solve for x now. 3x is equals to 24. Okay, divide both sides by 3. So what will happen? 3x over 3 cancelled. We have 24 over 3. So x is 24 over 3, which is actually the 8. Now, x is the smaller number. Agree? Okay? But, now, how do we find the larger number, which is the y? Because the problem is asking for the two numbers. So we can use this equation that we have derived. Okay? Any equation you can use, actually, in order for you to get the y. Okay? Can we use this? Yes. Can we also use this? Yes. Okay. So let's try. So if x is equals to 8, then we can substitute this freely from this equation or to this. So we can choose this. So we have y is equals to x plus 24, of which x is equals to 8 plus 24, that is equal to 32. Okay. Or if you're going to use y is equals to 4x, which is from the equation 1, that is 4 times 8 because x is 8. So that is still equal to 32. So, our answer here should be 8 and 32. That is the number. So, 8 is the smaller number and 32 is the larger number. Okay, let's try to solve again another number. Okay, in number 6, it says, if the sum of the three consecutive integer is 60, what is the smallest integer? Again, this is a problem that we've encountered a while ago wherein we have consecutive integers. So, we need to let, again, x, okay, since this is a consecutive integer, the first integer, okay, that is the x, consecutive. So, we have x plus 1, the second integer, and we have x plus 2, the third integer, okay, or the third number. Okay? It says if the sum of the three consecutive integers is 60. So we're going to get the sum of these integers. So we have x plus 1 plus x plus 2, okay, is 60. If the sum of the three consecutive integers is 60, what is the smallest integer? The smallest integer is actually the x. So, what can we do here? X plus 1 plus x plus 2 is equals to 60. Combining like terms, you have 3x plus 3 again is equals to 60. Okay. So 3x is equals to 60 minus 3. That is 57. 3x. So if we divide both sides of the equation by 3, so what will happen? X 57 is equals to 57 over 3, and that is equivalent to, again, 19. So this is the what we are looking for, the smallest integer, which is actually the x in our equation. Okay, so again, let's try another number. So for number 7, okay, let's try another problem for number 7. If the sum of the three consecutive even integers is 60, what are the integers? So at first, this seems to be very familiar, consecutive integers. But now we have added the word even. The problem has added the word even. Okay? So, solution again, of course, if we have three consecutive even integers, we must let, again, first, x is the first even integer, okay? And of course, if that is an even number, let's say 8, okay? The second consecutive even number to this is actually 10, okay? And the third the second one is actually the 12. Okay, so this is the first, the second, and the third. Okay, so what will happen is that if we represent this as x, in order for us to express 10 as in the value of x, so that must be x plus 2, correct? Because 8 plus 2 is 10. And if we're going to represent this 12 as x also, so we're going to have x plus 4. So that is basically the difference. So we can let x plus 2 as the second even integer. Okay, and we can let x plus 4 as the, let's say, third even integer. Okay, so that's the difference. If we have an even, or if we have a consecutive even integers or consecutive odd integers, we must first let the first even or odd integer as x, and the second integer as x plus 2, the third even integer or odd integer as x plus 4, and so on and so forth. Okay, so it says the sum. So we have x plus 2 plus x plus 4 is equal now to 60. So if we have this, x plus x plus x is simply 3x. Okay, 2 plus 4 is 6. We have 60 here. So 3x, 60 minus 6. We have 3x is equals to 54. And if we divide both sides by 3, so what will happen? X is now simply equal to what? 18. Of course, 54 over 3 is 18. Okay? So this is the first even integer. The second even integer is x plus 2, which is 20. Okay? And the third integer is actually x plus 4, which is 18 plus 4, which is actually 22. Okay? So that is our answer for this problem. Again, if we have consecutive even or odd integers, we must always what? Remember that it is not simply x plus 1 for the second integer or even or odd integer. We must always add also an even number or an odd number, okay? Even in the case of consecutive even integers or consecutive odd integers, okay? So let's try another problem. So this is last two of our problem. When the smaller of the two consecutive integer, again, consecutive integer. Okay, so if we have two consecutive integer, we have to let x as the first, and the second is actually x plus 1. Okay, is added to 3 times the larger, and the result is 59. So when the smaller of two consecutive integer, the smaller is actually x. Okay, when the smaller of two consecutive integer is added, that is plus to 3 times the larger, or 3 times the larger, 3 times the larger what? The larger integer. Okay, the result is 59, and that's denoted by equals to 59. Hence, we have already the equation. And we can now therefore perform or get the integers. Right? So we have x plus distributive. We have 3x plus 3 is equals to 59. So combining like terms, you have 4x is equals to 59 minus 3. 4x now therefore is 56 is equals to 56. If we divide this both sides by 4, what will happen here? We have x is equals to 56, of course, divided by 4. That is equivalent to 7. Okay? I'm sorry, this is not equal to 7. This is 14. Okay? This is equivalent to 14. Okay? So x is now equal to 14. That is the first integer. And the second integer is x plus 1, which is 14 plus 1 is 15. Okay? So down to our last example for this video. So we have this. If 6 is subtracted from the largest of the three consecutive odd integers. Again, if you see these consecutive odd even integers, you must again let x is equals to first odd integer. Okay? Again, as I've said a while ago, if we have three consecutive odd or three consecutive even, we must always use these values of x. For the first odd integer, we have to let x. Okay? For the second odd integer, we have to let x plus 2. So that is the second odd. Okay? And for the third, we have x plus 4. This is the third odd. Okay? So if you have already have these variables, then you can proceed to the given conditions in the word problem. So what will happen here? Let's try this first. Okay, if 6 is subtracted, okay, we have 6 subtracted, so we have minus 6. So if 6 appears from the first, no, don't be deceived. Okay? Satisfy first the condition after that phrase before actually putting minus 6. So, this is minus 6. If 6 is subtracted from the largest of the three consecutive odd numbers is x plus 4. Okay? So, we have x plus 4 here. Okay? If 6 is subtracted from the largest of the three consecutive odd integers, which is x plus 4, x plus 4 minus 6, that is 6 subtracted from the largest, with this result multiplied by 2. It means that the result of this subtraction from the largest odd integer is multiplied by 2. That is, with this result multiplied by 2, okay, the answer or meaning equal, the answer is 23 less than, okay, 23 less than, okay, that is subtraction, less than of the first, okay, of the first and twice, okay, the answer is 623 less than the sum, okay, the sum of the first and twice of the second. So the sum of the first and twice of the second integers, which is actually x plus 2. Okay? So again, let's have a recap. So if 6 is subtracted from the largest of the three consecutive odd integers, again, this is the largest consecutive odd. 6 is subtracted from is, this is now the equation or the expression. With the result or with this result multiplied by 2, this is that. We multiply 2 by the result of this subtraction. Okay? The answer, which is equal, equivalent to equal, is 23, okay, less than the sum, okay, the sum of the first, which is x, okay, and twice, plus, this is the sum, okay, first and twice the second of the integers, or second of the integers. I have a wrong spelling here, so we have second here, okay, of the integers. This is twice the second of the integers. We're getting the sum because it says the sum, okay. Find the integers. So as you can see, if you have already set up the equation, then the algebra will do it for you. So we have x plus 4 minus 6. We can simplify this as x minus 2 is now equal to x, okay, plus 2x plus 4 minus 23. So what will happen here? We have 2x minus 4. We have x plus 2x is 3x plus 4 minus 23. Combining like terms. So here we can simplify this. 2x minus 4. 4 plus 4 minus 23 is 3x minus 19. Combining like terms, you have 3x minus 2x is equal to what? Is equal to, we have transpose this 3x minus 2x, we have negative 4 plus 19. So that we have x is equal to negative 4 plus 19 is 15. Okay. So this is now our first odd integer. Okay, find the integers. That's the question. So if x is equals to 15, then definitely the second odd integer is x plus 2, which is 15 plus 2 is equals to 17. Okay, and the third odd is x plus 4, which is 15 plus 4, which is equal to 19. And that's it. I hope I help you in your struggle in solving number problems, particularly this number problems, this basic number problem. So thank you so much for listening, and God bless you.